PewDiePie, and in today's video, I'm just going to be talking about limits. So I mentioned limits in my first video about derivatives, and this is only going to be a very quick topic. I'm only going to be going to very little detail about limits, again, because limits itself is a very big unit. If you guys do want more about limits, please check out my website. I do have a full set of notes explaining everything about limits, but this is only a quick video about limits related specifically to derivatives, right? So I'm just going to give you guys the basics. So what are limits? Limits are used to see what the function value is approaching, and I underlined approaching because it's not what the function value is equal to, but what it's approaching as the x value approaches a certain number. All right, and that's basically it. If you guys want, I'm just going to draw, I guess, a quick diagram for you to kind of explain what I'm on about. So let's say I want to figure out the function value when x is here. Let me just make another color. All right, so the limit, this is just going to be a very quick thing. The limit is basically what the function value is approaching at this specific x value, right? So it's not what the function value is equal to, it's what it's approaching, and there is a difference because it depends on when it's approaching from the right hand side and from the left hand side, right? And that's pretty much it. I know that if it does not make a lot of sense, please check out my website. I do explain it in full detail. But again, the sake of this video is just to talk about limits in relation to derivatives, right? So we can also use limits to find derivatives. And I mentioned this in my first video about derivatives as well. And there are two main formulas we can use that will allow us to find the derivative using limits. And here they are. So formula number one, it's over here. M is equal to the limit as x1 approaches x0, f of x1 minus f of x0, x1 minus x0. So essentially all you're doing, this is kind of similar to your slope formulas. If you guys can remember the rise over run, where we did like y2 minus y1 or y1 minus y0. It's kind of the same thing pretty much. Yeah, and it's very straightforward, very simple to use. But my preferred method would actually be formula number 2 here, which is m is equal to limit as h approaches 0 for f of a plus h minus f of a all over h. So h in this instance actually refers to the distance between 2 points that you're using to try and figure out the limit and the derivative in this case. And a is pretty much just equal to x. So is a is equal to x. It just means it's pretty much similar meaning. It's just in the formula in my notes. I wrote f of a plus h minus f of a, so that's why I wrote it down as this, but you could also equally as write f of x plus h minus f of x. And the reason why I like to use formula number 2, and it's also the rest of my class and my teacher as well, because we found it to be easier to remember, and we found it to be used more frequently and more commonly, and we found it actually surprisingly easier to use than the first one. All right, so I have an example here, a practice problem. For the function y is equal to x squared plus 1, find the derivative at x is equal to 3. So this is a particular derivative. If you guys want, check out my video, Derivatives Day 1 Part 4, about general versus particular derivatives to find out more about that. So basically, I just wrote the formula I'm going to use right over here. So I can remember what my formula is, because please guys remember to show your steps and do everything one step at a time, because you can easily get something wrong if you try to skip steps. So even I, who's done this multiple times, I still write down the original formula to remember what I'm doing. And I just want to highlight something. M here is the same thing as derivative, and the reason for this is because this is the slope of the tangent line, which is pretty much what a derivative is. A derivative finds the slope of the tangent line. So they're pretty much equal. So you can write dy over dx at x is equal to 3, or you can just write m. Now for the sake of this unit, I will write dy over dx at x is equal to 3 equals limit of h as it approaches 0 of f of a plus h minus f of a all over h. All right, so now we're going to go ahead and solve it. So I'm just going to write down the original function so I can remember that as well, because I will need it. And I will write dy over dx at x is equal to 3 is equal to limit as h approaches 0 of f of x plus h minus f of x all over h. Please don't forget the all over h. Sometimes people get too distracted with the top that they actually forget the bottom. and that will result in a wrong answer. And this is the part where I want you guys to pay attention. So when it says f of x plus h, all that means is you are going to add f of x plus h. Let me use red to highlight it. You're going to add f of x plus h wherever you see an x in the original function. So this right here is the original function. And we see that there's an x squared. So you're just going to plug in x plus h into that x squared. And then that's it. And then the plus 1 stays the same because there's no other x there. So basically, wherever you see a variable, you just plug in x plus h, or whatever that variable is, z plus h, r plus h. You just plug it in to wherever you see a variable. And I'll elaborate more on this as I continue to show my work. Another thing, please leave the limit until the very end. Don't solve for the limit until the very end. I'll also talk a bit more about why we do that, but just leave it until the end. So for the f of x plus h, what happens is that all we do is we get this x plus h in brackets all squared plus 1. So you see what I did there? So there was an x squared. What I did instead was I plugged in x plus h into that x. So that's why it's x plus h all squared, because I literally just plugged x plus h into x. And that's all you need to do. So for example, if there was multiple variables, if this was like x cubed minus x squared, I'd plug in x plus h into both of them. So it would be x plus h all cubed minus x plus h all squared. All right, so it's very simple, very straightforward. Some people might first be thrown off by this, but it's very simple. And then from here, it's all downhill. Minus f of x, just minus the original function, which we already have, x squared plus 1. Please write it in brackets so that you guys remember that this is a negative for both components of this of everything inside the bracket. Sometimes people forget and they rush it and they only write minus x squared plus 1, but this is wrong because this negative sign goes into everything inside the bracket. So it's very important to write the bracket so you guys can remember. Again, the important thing is just take your time and show all the necessary steps, because it's not just good for your marks, but it's also good because it helps you remember, because there can get a lot of steps and it can get tricky if you try to skip steps. And then the bottom also stays the same as well, all over h, that doesn't change, right? And now all I'm going to do is I'm just going to open up my brackets and expand as h is approaching 0. All right, so x plus h all squared, that gets us x squared plus 2xh plus h squared plus 1 minus x squared minus 1, because that negative sign again goes into everything. All right, and notice how the limit stays. I'm not doing anything to it until the very end. All right, so what I can see from here is that these two cancel out, because a negative and a positive, they cancel each other out. This negative 1 cancels out with this positive 1 for the same reason. And so all we're left with is just h squared plus 2xh. So h squared plus 2xh all over h. Sorry if this looks like an n, but it is an h. So now what I'm going to do is I'm going to factor out an h from the top. So it becomes h plus 2x all over h, right? Now I'm going to go to the next page, equals limit of h as it approaches 0. I factor down h here, and this should be h plus 2x, h plus 2x all over h, right? And so these two cancel out, and now I can apply the limit. So I get 0 because so when h is approaching 0, basically we just substitute 0 into h. If you guys want to know more about why we do that, please check the notes on my website. Plus 2x. And so the derivative, the general derivative, is 2x, right? So we still have not found out the derivative at x is equal to 3. So please remember that this is not the final answer. This is still a work in progress. So all we do now, it's actually very simple. To find the derivative at x is equal to 3, we're just going to plug in 3 into x. So we're just going to plug that in. So 2, 3 is 6. So the slope of the tangent line at x is equal to 3 for the function x squared plus 1 is 6. So this is my final answer. All right, and now let me go back and talk about why we leave the limit to the end and why we take out a common factor of h. So the reason we do this is, again, because if we do not take a common factor out of h and we do not cancel the bottom, we have a 0 here. If we put in a 0 into the denominator, we will get an undetermined value, right? So what that means is, and I'm sure you guys have learned about this, but basically if you have 0 in the denominator, you will not get an answer, you will get an undetermined value. And undetermined, please pay attention, does not mean there is no solution. Undetermined, again, like the word suggests, it's just not determined. We don't know if there is a solution. There might be one, there might not be. It's unknown. So if you get undetermined, what that means is that there's either another way to do this problem or there is no answer. But it does not mean there is no answer. So just keep that in mind. So that's why we take out an h, and that's why we leave the limits to the end. Because if we do the limits and we cannot factor out an h, we will get 0 in the denominator, and again we will get an undetermined value. So that's why we do that. And also pay attention, we got the general derivative here. This is the general derivative. So remember, it's not your final answer. It's just the general derivative. You need to still plug in the 3 into x to get the slope. And the slope here is 6. Right? So I'm just going to write slope. Actually, I'm just going to write the derivative. I don't know about your teachers, but usually in my class we had to write a sentence after we found a problem. The answer, the derivative of the function at x is equal to 3 is 6. Right? And going back to my first video about derivatives, this is kind of the same reason why using differentiation rules is so much easier than using limits, because look at how much work I had to do just to figure out the derivative. Whereas if I use differentiation rules, if you guys haven't watched that video, please go watch it. It's very important. X squared plus 1, right? If I take the derivative of this, it's so easy. I can just use the power function to find the general derivative. I'll just use the power function, so the 2 comes down. And 2 minus 1 is just 1, so x just stays, and then the derivative of a constant, again, is 0. So y prime is equal to 2x. And that is literally the same general derivative we got over here. But look at the difference in work. We had to show so much more work just to get the same general derivative. And then from here, if I wanted to find f prime of 3, I could literally just, again, plug it in, and I would get 6. So the same answer, except in way less work. That's kind of why differentiation rules are so important to derivatives. But it's also very important to know how to use limits in terms of derivatives, because it can act as a way to check your answer to make sure you did it right. Obviously, if you have the time. But that's it for today's video. I just wanted to talk to you guys a bit more about limits and in their respect to derivatives. Limits are important to know when you're learning about derivatives, because they'll help you understand derivatives better. Because limits also deal with slopes and graphs and all that good stuff. So they're very related in that sense. Again, if you want more notes about limits, please check out my website. Link is in the description. And if you guys have any questions, concerns, or comments, please email me at helpwithmath0@gmail.com. Again, that will also be in the description below. Thank you guys so much for watching, and have a great day.